A careers in RE class that's happening at Century College at Ralph Jacobs is teaching. All right, Ralph. Oh, there you are.
I won't be wearing this shirt, so you won't recognize me.
And then we have our new Solar Sisters group, which is it's just a free gathering. We're trying to encourage more women to become involved in renewable energy. So that is touring a house that has solar PV and geothermal, and it's been remodeled to Green Star standards. And then we do have a class, Understanding Solar and Electricity for Your Home, and that'll be being taught by Carol Weiss from Solar Energy International. She is in town from Colorado and is teaching a class for us. We're trying to have it be women majority, but what we'll do is we'll try to sign up as many women as we can, and then we'll sign up men to equal that amount of women. So right now we have 9 women signed up, so we can sign up 8 men. So that'll be at City Academy in St. Paul on March 28th. And Carol will be going over electric bills, talking about what you can do to reduce your electric use, size the system, price out the system, and then talk about rebates and incentives that are out there. What else is happening? Yeah, I think that's about it. Ralph, do you have your classes scheduled yet for the next round?
Mike would know, actually. We don't.
We don't, yeah. So we'll get them going. Anything else?
All right, thanks, Laura. Laura, by the way, is our managing director at MRES. The other thing that I guess we could have mentioned, I should have mentioned earlier, is that if you're new to MRES, we have a lot of committees that are active, advocacy, events, training, outreach, etc. And so if you're interested in any of those, you can again check on the website. There's a lot of good information there on those, and we'd love to have you involved if you have the time. So now I'd like to introduce Dwight from Cardinal ST, and a wonderful company we have in Northfield, Minnesota, that I think could really change a lot to do with solar in our area and everything. So Dwight, you want to come up?
Sure.
I'll let you finish introducing yourself.
All right, thank you. I think I've got this down. My name is Dwight Kolosik, and I do work for Cardinal Glass Industries. And I'll explain a little bit more about the ST solar technology division of that as I go on, but a little bit about myself. I was raised in Kansas, started in the glass business about 23 years ago in Kansas in what we call a float process, and that's the process in which you actually manufacture the glass. I was in that for about 10 years and moved out into the coating end of glass, which brought me to Iowa. Was there for 10 years, where we were putting energy efficient low E coatings on glass. About a year and a half ago, I left Iowa and I came to Minnesota, and I'm coating glass in Northfield, Minnesota currently. I think I'm going the wrong way. I mean, seems like every several years it gets a lot colder, but I'm getting used to it, and I've enjoyed Minnesota, and look forward to many years here. First, a little bit about Cardinal Glass. Come over here. It was first established in Minnesota in 1962. Our corporate headquarters are in Eden Prairie. Right now, we've grown to approximately 5,500 employees across the United States with 29 plants. What we do is we supply products to the window and door industry, primarily insulated and coated glass. Since the beginning, we have been concerned with energy conservation. Cardinal was a pioneer in the insulating of the double pane glass. You can remember back when that hit back in the 70s, that didn't work very good to begin with. Now we manufacture insulated glass units that have a 0.2% failure rate after 20 years. So everything is going really good there. We do manufacture triple silver low E coatings, which are some of the most efficient, energy efficient low E coatings on the market today. So in Cardinal Glass Industries, we're really divided up into 5 subsidiaries. We have Cardinal IG, the insulating glass portion of it. We have Cardinal CG, the world's largest coater of residential low-E coatings. IG, which is the insulating glass, or LG, excuse me, the laminated glass. FG, which is the float process, the glass manufacturing. And then the newest addition is Cardinal ST, solar technology. Looking across the United States, this is where our plants are located. As you can see, we are concentrated in the upper Midwest. Minnesota and Wisconsin is where most of our employment is. On the same token, that's where our largest customers are also. We are not outside of the United States yet. All of our factories are located in the United States. Okay. So in Northfield, the plant was built in Northfield in 1987. We do produce energy efficient low-E coatings, single, double, and triple silver low-E's for the commercial, residential, and commercial building industry. Our annual capacity currently is 84 million square feet of glass. And historically, we've employed somewhere between 120 and 140 people. In the past 3 years, because of the issues in the building industry, we've seen our sales decline by over 50%. Our employment is down to 90. And beyond the future of the plant was in question. This is what the housing market did as the bubble burst. Right now, as a company, Cardinal has capacity to service housing starts up to 2 million. And this year, if the most optimistic projections come true, it'll be around 660,000. So obviously, we've got a lot of coating capacity, and some hard decisions had to be made. But then came knocking on our door, the phone started ringing, and the solar market started to expand. There were a lot of people interested in developing new coatings, and so we signed a joint development agreement with a solar company, and we've been working on that for over 3 years. When we look at what we predict solar cell production to do in the next several years, by 2015, we're looking at a pretty dramatic increase. In fact, right now the solar business we believe is somewhere around $2.5 billion by 2015. We think that's going to be a $15 billion industry. The sector that we're in is thin film. Right now, thin film accounts for about 10% of that market. In 2015, we think that thin film is going to be about 40% of the market. So not only is the market going to grow, thin film is going to account for the lion's share of that growth. So with our roots being in energy conservation and offering those products, it was a natural step for us to start Solar Technologies. And it's our idea to fabricate the most advanced products for the solar industry today. Right now, for solar products, we make solar float, mid-iron and low-iron glasses that increase the solar transmission by up to 2.5%. Solar tempered products that we make for the backlights for thin film modules. We make encapsulation machinery for the solar cell makers, the photovoltaic cell makers. And then in solar films, we make transparent conductive oxides, we call them TCOs, AR coatings, anti-reflective coatings, back metallization for the SIG cells, and low maintenance or super hydrophilic coatings that keep the surface of the glass cleaner, increasing transmission on solar cells. So what that's done for us, it's brought us 100 million square feet of new solar float business. That's produced in our Portage, Wisconsin plant. 100 million square feet of the tempered backlight business for thin film modules. That's done in Chehalis, Washington, and Mazomanie, Wisconsin. Our solar customers are the largest consumers. We feel that the solar customers are going to be the largest consumers of glass going forward. I think the window industry, it'll come back slowly. It'll never be like it was. And solar is where the glass is going to be. So with this opportunity, we were able to negotiate a supply agreement with the company that we went into joint development with. We're going to construct a new coater. When the project started, approximately, say a year ago, when we decided to commercialize the coating, it was a $30 million project. Today, we're up to $46 million. And I hope that starts leveling off sometime soon. But what we've decided to do is, instead of converting a coater, we're going to build a new coater. And keep the coater we have currently operating to supply other solar products to the industry. So the employment currently at 90, we're expecting that to go up to around 140 to 160 people, probably in the next year and a half. And what's that?
In Northfield?
In Northfield. And so with this contract, when the new coater's built, that's going to sell us out 24/7 for the next 7 years. And we know that the coating isn't going to stay the same for 7 years. And I'll talk about that a little bit later on some of the problems with that. So the kind of coatings we're doing vacuum deposition coatings. And the TCOs we've developed over the last 3 years are done under a patent from NREL. NREL developed the coating, and we're fine-tuning it. In fact, 3 years ago, when we were approached, we were told, we've got this coating, it's pretty much all done. We think we're just going to have to tweak it a little bit. So we're 3 years into it, and we've been doing a lot of tweaking. And so it's interesting on how that path is taken. We wanted to be in production at this point in time, but with some of the technical issues that we've had, that's been pushed off. I think right now we're in pretty good shape. We've run our first round of qualification, and we expect that to be done by the middle of the summer. It is thin film CAD-TEL technology, and again, we're using vacuum deposition. Yes, sir?
Now, are you, the ratios you're looking for export, this is domestic use?
It's mostly export.
Okay.
Yep. I wish I could say different,
All right.
but it's not. So the suppliers, or our customers, again, are the largest manufacturers in the world. The innovative coated technology, and we're looking to make 80 million square feet of TCO cells just to this one company in 1 year. To do that, we have to transform our factory. Right now, with the low E coatings, while in their day they were pretty technical, and it's taken a lot for us to get to where we are with that. With the solar coatings, they're a lot. You have to be a lot more precise, less variation to get the maximum amount of efficiency out of a cell on the average, because that's where the solar cell makers really bring in revenue, and that's the watts per cell. You have to be consistently in the upper range to make it work. So we're bringing in closed-loop control systems. We've been actively pursuing those for the last 2 years, and retraining our workforce to do SPC and instant control on the process. So if our projections are right, the glass that we make in 1 year should supply enough solar power to eliminate the need for 2 coal-fired electricity plants. So over the 7-year period, we're talking about 14 plants that'll be eliminated, or they won't be eliminated. You won't have the need for them. Hoover Dam, the backlights that we currently make for thin film, the tempered lights, they've gone on enough solar cells to equal about half the power of Hoover Dam. So we're not talking about small potatoes here. It's pretty good. So some of the opportunities that exist as I see them in the solar industry. One is the advancements in technology is really increasing the efficiency of solar cells. Right now, thin films traditionally are 6 to 12%, crystalline silicon 15 to 20%. Everybody has got champion cells that are a lot better than that right now. I know our champion cell is much better than that. So as that goes, and everything's moving really quick. In fact, 3 years ago, when we started this project, our goal in the percent efficiency that we wanted has gone up 1.5% since we started because of the improvements that have been made in the processes. Another opportunity is manufacturing advancements. Right now, the manufacture of solar cells is relatively a slow process. There's a couple companies out there, on the thin film side anyway, that have really sped up their line speeds to where they're really producing a lot more product in the same amount of time. Governments supporting renewable energy sources. I think that's critical in the beginning stages to get the funding and the capitalization of the project. There's a ton of people right now that are just on the cusp of going into production. They've developed their devices, they're ready to go, and they're hamstrung because they can't get money. We've helped out a lot of these guys to where either through financial investment or working out deals to where we will sell them equipment for their processes. But it's really hard. Germany, the largest solar market, has reduced the subsidies that they pay up to 15-16%. In arable land or farmable land, I guess I should say, they've cut out subsidies altogether. So some of that's really going to change, and by that move, we feel that it's really going to change where the growth centers for solar are, which we feel are going to be North America and the Asian Rim coming up. And then another thing I feel is replacing building materials with electricity generating products. I don't know, I hope I don't offend anybody by saying this, but when I'm from northern Iowa, there's a lot of windmills in northern Iowa. And I worked with several of the companies through economic development when I was down there to bring those projects to northern Iowa, and they're great. Bringing a lot of employment, generates a lot of clean energy. But after you get so many of them, you got to think to yourself, when's this going to stop? I mean, how many windmills can you really put everywhere? Same with the large generation of solar cells. There's already people objecting in the Southwest, in the deserts, on the large solar utility scale generations. So, and I think one of the challenges, and I think there's people doing some great work in this area, is to make shingles or siding for houses that generate electricity. So you have a bunch of micro producers instead of macro producers. I think it's going to take a little bit of everything. It's going to take the macro producers, it's going to take the micro producers, and it's going to take conservation also to make all these things work. Some of the threats that we've seen, this is the double-edged sword. The advancements in technology increasing the efficiency of the cells. You say that was an opportunity on the last slide. It's a threat on this side. The solar business is very capital intensive. It takes a lot of money to build the manufacturing equipment to produce solar cells. Some of the materials take special handling. It's expensive. As fast as the technology is moving, I don't know that you can get the money out of the equipment that you buy before it's time to reinvest. And that's going to be a challenge to figure out a business model that's going to allow that to happen. Reduction of subsidies. As the price of oil goes down or whatever happens, economic constraints, the reduction of subsidies in the short term anyway, I think are going to be a threat. Price erosion. About a year and a half ago, thin film was selling for about $2.40 a watt. Today, depending upon who you listen to, I've heard as low as $1.40 a watt to $1.70 a watt, which is really great for the consumer, but when you're trying to capitalize an industry, price erosion can really hurt you. And then finally, when I was asked if it was going overseas, the question is yes. So transportation costs. You know, it's with the industry being capital intensive, it really shouldn't matter whether you're making it in China or the United States or Timbuktu as far as that goes, because just a minute, because the equipment's going to cost you the same no matter where you put it. Government policy has a big hand in that, but then you've got to move it to where they're making the solar cells, and that's what's going to cost the money. It costs me just about 25%. We project it's going to be about 25% of the product cost is going to be in transportation. And that's huge. Yes, sir.
Okay, just if I could push you a little bit on that price erosion to see what you think is really going to happen. It seemed to me that in 2006, maybe the solar industry, the worldwide PV industry kind of maxed out the supply of silicon, and then because of the Kyoto Accords going into effect, and suddenly there was a big surge. And
There's plenty of silicon now, isn't there?
well, and the thing is, then, you know, just as these things are coming online, the economy tanks, and now it seems to me that a lot of my suppliers just wouldn't be going that low, except that they're trying to hang on to market share, which means they're only selling on the margin rather than try to recover their capital costs.
That's true. And that's a certain part of it. They're trying to, with the huge capital costs of these plants, they're trying to move product through, keep things running. And with the price going, and there is plenty of silicon in the market now.
Which
and,
means that in 2 years, let's say if the economy is picking up, does that mean we're actually going to see price start to bounce back so that they can recover their capital costs?
I don't know. You know, when you're trying to achieve more grid parity, you really don't want the cost to go up. You want to become more efficient at manufacturing, which is hard to do when you can't capitalize. But another thing I've seen on that same idea is that I've seen some of the larger solar cell manufacturers actually financing utility scale projects, where they'll go in and they'll buy the land, they'll set it up, and then they'll sell it to a utility and maintain the maintenance contract or something like that on it. So they're using some of their own money to try to keep the ball rolling. Yes, sir.
I mean, with the transportation costs, the fact that they are, it seems like it would make sense that some solar manufacturers would want to locate close to Northfield to take advantage of not having, or at least in this area or whatever. I mean, are you seeing anything along those lines that might be a good sign?
No. The solar manufacturers are going to locate the closest to their markets, is what they're going to do. And with the United States being one of the growth markets in the future, you know, you would think that there'd just be a lot more going on here. And I think it's very difficult, and I can't honestly say that I completely understand it. But you've got companies like Evergreen that are shutting down capacity and moving it overseas, and then you've got overseas companies, Yingli and some of those guys, that they're building factories in the United States. And it just seems backwards to me on how all that's working. And you know, there's a lot of reasons for that. It was just what pocket you're putting your money in and all these other things. But it is kind of frustrating. So I think that's really all I had. You know, I wish I could go into more specifics about the coatings and the device that the parts that we're making, but I really can't do that. Yes.
Maybe this isn't too specific on that point, but you mentioned in there that the technology for the thin film, or whatever you call it, was cadmium telluride technology.
Mhm.
Now, I know that cadmium is extremely toxic. So my question to you is, are we coming into a place where we can replace really toxic materials with more earth-friendly materials? And is there ever an issue with this cadmium leaching out or whatever, if a person has it on the side of their house or in the windows?
We've not seen that. Well, you've asked several questions. Let me answer the first one. There are different materials that are finding their way into photovoltaics. Some of them are more safe than others. So the trend I'm seeing is that the higher efficiency cells are using the materials that aren't on the safer side. Okay, so with that being said, the thin film industry is spending a lot of time and a lot of effort, and they are very concerned about the materials they're using. In CadTel, you've got CadTel, Cad sulfide, Cad chloride, all of that's in there. So they're really concerned about that. So not only have they set up recycling centers for their cells, but they constantly monitor what's going on. And looking at some of the data, there is, in my mind, no reason for alarm. The materials have been handled safely for years, and they'll continue to be handled safely. But there's just some systems that need to be put into place, so if a solar cell fails, you handle that responsibly. And that's a big deal to all the thin film folks. That is number one on their list. Longevity of the cell and the cadmium. Because if you think about their industry, that's really two of their biggest threats.
Question in terms of where is the product development or the R&D? I mean, is that being done at Cardinal, or is that part of the JDA, or does it depend on what type of glass you're manufacturing?
We're doing that at Cardinal. We have a coater, a vacuum deposition coater in Spring Green, Wisconsin, that we have dedicated to this project. And that's cost millions and millions of dollars. But that's how strong we feel about solar, that is the wave of the future. And if we want to grow our company, that's the direction we're gonna need to go.
So you have an R&D group or
Yeah.
product development group?
Right. We employ about 35 technicians and scientists in our R&D facilities, in our coating R&D facilities. Yes, sir.
Are you selling strictly to utilities, or do you sell to residential?
Right now, we're all in utility scale projects.
Do you have contracts with overseas utilities?
Well, again, we're not making the PV cell. We're selling to the people that are. So they would be the one that would be procuring those contracts, not us. We hope they do. We hope they have a lot of them. Yes, sir.
Following up on the price question, something I read just recently, that the drop in price has driven single crystal cells down near some of these same levels, and given the differential in efficiency, that may squeeze the thin film market. What do you see on the horizon for that?
Well, first let me say one thing, that any kind of forecasting with solar, I think is a lot like the weather. That you can go online and you can find somebody that's going to tell you what you want to hear any given time. But to answer your question directly, that the crystalline guys have gotten a lot better, a lot cheaper, and a lot faster. So they have really improved their product. So their costs are coming down and their efficiencies are going up. They have champion cells, north of 35–40%. And so, it's going to be a race and see which technology is going to be able to produce the most efficient, cost-efficient cells in the future. Yes, sir.
You kind of answered one question. I was going to ask you how much higher your champion cells are than the rates listed on the board, and also, do you think thin film, in your opinion, will catch the efficiencies of the regular solar panels?
Well, to answer your first question, there's people that claim with crystalline silicon that they've gone over 50%. Okay, I've never seen one of those cells, and so I don't know that for a fact. I do know through our intelligence that there are people around 40% or better. In thin films, our champion cell, rather not say, but let's say that there's guys that are around the 20% range. And again, a champion cell is not something that you can produce on a day-to-day basis. It's done under very close laboratory conditions, and sometimes they're just flukes. When we look at our data, there'll be cells in there that I wish I could produce every day, but we can't. But I do think that's going to continue to improve. One of the greatest things I think that's come out of this whole mess with the energy and the economy and all of that there's a lot of brain power going in to renewable energy. And the technology is just moving so fast that at some point in time, it's got to slow down, but it's going to benefit everybody. Yes, sir.
Is there a difference in the degradation between thin films and crystalline?
You remember, you're talking to a thin film guy. Okay, all right. I'll qualify that. We do some pretty extensive tests, and while we don't make the cell, we take them and test them because we have a lot of the test equipment through our IGs and some of the stuff that we've done, our insulated glass units. But there's no reason for us to believe that a thin film cell can't last 25 to 30 years. We can't prove that because there are really not that many out there. The crystalline, they can say, well, we made this in 1970. It's still good. Of course, the rate at which it generates electricity goes down. But to say that for sure, I can't. I can tell you that our testing shows us that we can. And every year we'll put a notch on our gun belt. Say we got one more year. Yes, sir.
In your vacuum deposition closed-loop system,
Mm-hmm.
how much variability can you have in the production? How does that translate to the variability in the efficiency of the cell once that's produced?
There's a number of attributes that we look at. And one of the most difficult things about making the product, the TCO that we make, is that before it gets put into a solar cell, you have to transform the coating, excite the electrons, line everything up. So when it comes off our line, we might have sheet resistance, a measure of conductivity that might be 16 to 20 ohms per square. And in the cell, it needs to be 5 or 6 ohms per square. So it's kind of hard to figure all that out in what we're doing, but we're trying to make the product so we don't have to land on the head of a pin every time we coat, because there is variability. I don't know if you're familiar with vacuum deposition, but there is a lot of variation in that. So, you know, I'd say generally speaking, if you look at the thickness of the whole layer stack, which will be somewhere in the neighborhood of 4,500 to 5,000 angstroms, we would have a variability of probably 5 to 7% on that, depending upon which layer it is. If you have that variability in your blocker layer, it's not as important if it's in the CAD layer or the buffer layer.
And follow-up to that is, how much are you monitoring the technology of the vacuum deposition, and the advancements in deposition techniques?
There's several different schools in that. There's the semiconductor school, which are very small scale in our mind. And then there's large area coating is what we do. We are the largest large area coating company in the world. So I'd like to think that we stay pretty close to the cutting edge on that. You know, not to say that we don't learn something every day, but we're pretty good on that. I'll get you.
So as he was talking about, I'm just kind of curious what kind of instrumentation you're using to measure the thickness.
Well, there's several ways we do that. One, we can measure it optically, to where we have models that by transmission and reflected color or transmitted color, we can kind of tell what the thickness of the layer stack is. We can do all that inside the coater. So when we get done putting a layer down, we can look at it and model it spectrally, so if we know we're putting down the same coating or not. So that's one way, and then another way is the good old-fashioned way is when you use a step profilometer and actually measure it. Plus or minus, I think it's 50 angstroms.
A little different question on those 35 R&D jobs you were talking about, or those positions, are those in Wisconsin along with?
Yep.
That's in the R&D.
Yep. In the coating. Now we have R&D for insulating in Minnesota, in the cities here, but.
And for the Northfield, when you do expand, what type of skills would you be looking for?
Well, the skill sets are changing. Kind of give you a fairly long, not too long of an answer. But when we first started in 1987, we would pick up a piece of glass out of a case and we would set it on the line and run it down. Then we'd have somebody pick it up and put it into a case. All right. We had our incident rate for accidents was around 45, which is horrible by today's standards. And the reason why we're so much better, last year we were 2.5. And the way we do that, because we're loading automatically now, to where the employees aren't physically touching the glass. We've got robots that are picking it up, putting it online. We've got robots that are going to take it, cut it, and do all of that. So the skill set of our employees has gone from what we call glass handlers to people that can work on those robots and keep them running. So the skill sets have gone up. And we've partnered with Dakota County with training programs to where our maintenance employees and some of our shop floor employees are going to be retrained for their new positions. So.
That was actually my question. What are in the next 5 to 10 year time frame, where are the critical needs we're going as an organization that advocates for solar energy and green jobs? What should we be telling people to train for?
I think it's going to be on the technical side. On the maintenance skills, you got to be able to understand programming of robots and handle all of that. From the coding side, we're going to have to, we're not just going to be able to have anybody run those coders and maintain those coders. So everything's pretty technical. Electrical engineers, typically that's the engineers. When we look for engineers, we're looking for electrical engineers. And we use a lot of power in our process and vacuum deposition. So that's what we're looking for. Yes, sir.
How about materials science?
That's good too.
Yeah.
What's that?
Do you hire material science?
We have some in the R&D. A couple guys, in fact, one of our brightest guys came out of material science. And so I left that one out, but you're right. Yep. Yes, sir.
What is the degree of dependence, technology dependence, for your productivity? One of the arguments that we run into in trying to convince policymakers that we ought to incentivize the supply side in solar is that to do that is picking winners and losers. And we're trying to convince them that there's a significant portion of that investment that is not dependent on the technology. Are we telling them the right story, or is it actually so dependent, the technology and the automation and the machinery, that in fact they're more correct than we are?
Well, I don't know how I would divide that up right now on what that would be. My preference would be always to lean towards technology. So I don't even know if I can answer that question, to be honest with you. Check back with me in a year. And I'm pretty sure a year from now I'll know exactly what I needed. So. Yes, sir.
Have you gotten any incentives from government?
Yes. We're among a handful of companies in Minnesota that qualified for the 48C income tax credit. Cardinal, we were given $7.7 million for our project. And again, those are tax credits, so if you don't make money, it's kind of hard to use them. So we're optimistic, but there were several other companies in our area here that received them also. Viricon down in Owatonna, they received some money, and one of the largest recipients that I saw in this area anyway was Sage in Faribault with their electrochromics. And in fact, last week it was announced that they've got a DOE guaranteed loan for $700 and some million dollars, or $70 million, I guess it was. And so they're moving forward with commercializing their product. So it's good to see that some of that's coming in to the Midwest. Yes, sir.
Although I know that glass is your stock in trade, one of my favorite products for let's say doing double duty as a building material was the unisolar shingle, flexible.
Mm-hmm.
And I wonder if you're working with flexible. I mean, thin film seems to lend itself so well to flexible materials.
Right. We have not done any work in flexible substrates. Have not. Again, I believe that's got a huge place in the future. Dow Corning was given a DOE loan guarantee to convert a factory to shingles, solar shingles. So it'd be interesting to see how they come out on that. But I think that's when I talk about micro producers, that's what I'm talking about, things like that. You guys ask a lot of questions. Yes, sir.
Maybe I'll piggyback on that. How about roll shingle? Would that be something where thin film might work?
Well, I understand the generation part of that technology. With us not being real close to it, I don't know. I would think you'd be able to do that. You can use an inkjet printer to make a solar cell. Not very efficient, but you can do it. So, I would say the possibilities, and just use your imagination. And that's one of the most exciting things about the solar industry right now, is the technology is just exploding. And, you know, I get all of these emails every day from, you know, all the market watches and the technical stuff. And some of the things that come out of there, it's just incredible what guys are working on. Yeah.
Is there going to be any expansion on the plant itself? Did you say if that is in Northfield, for example?
In our design, we've got a two-coder design going. Initially, we won't do that, but obviously, if you plan that at the start, there's certain cost advantages that you have if there is a second coder put in. Instead, so we're set up to do that, should that happen. But we're also keeping open our current coder, and we're going to be looking at making AZO coatings, aluminum zinc oxide coatings, both hazy and not hazy, and looking at making the anti-reflective coatings on that coder, and kind of doing other solar work on that in Northfield, and that's what's really bringing up our employment from 90 back to 140, 150 up in that area, is the fact that we'll be running two coders instead of just one. Maybe someday three. City's going to have to give us some variances on our building if that happens. So if you're talking to somebody from Northfield, just mention that to them.
What about the people that you guys are looking for? I know you're looking with DCTC to do some training, but I mean, are you finding people out there in the area that meet your employment requirements, or does pretty much everyone that is in the area need training to do what you need to do?
I'm optimistic that there's people out there that with very little training will be able to jump in and understand what we're doing. Again, I'll know a lot more 3 months from now, because we've just really, we're at a point in the project to where I'm comfortable enough to go out and really start hiring some people, and we're going to start trying to hire some of our technical folks.
It just, to follow on that question there, it just seems like there's sort of a threshold that you're crossing where you're going from people that are graduating from programs in the technical colleges to people who are graduating from the universities, like engineering background.
To a certain extent. I've worked with a lot of guys that have come out of the technical colleges that are really good. So there's a certain amount that depends on the individual. But there's some of those guys, I would rather have them than the PhD guy, because when it comes to getting on the machine and making it run, they can do that. And they might not understand the theory, they might not know all that. They don't need to know all that. They just need to keep my machine running. And so those guys are great. And we're going to be looking at a lot of people at that level. And then, you know, even undergraduates, you know, sometimes you're looking at masters and above also on some of that. Yes, sir.
You have a solar system on your roof?
No. You know, that's kind of, you know, I think about this all the time, and I'm kind of showing you my dirty laundry right now. But, you know, we're going to be making parts for solar cells, which is really a great thing, you know, and that's renewable energy and all of that. But as we started down this path, I started looking at our factory, and again, it's 23 years old, and, you know, from an energy efficiency standpoint, we're not really very energy efficient. I mean, I'll hop in my Suburban and drive, you know, down the street, and you know, so as we've gone down this road, we're looking and working with Xcel Energy and a lot of other things to where we can actually conserve energy. There's some things you were talking about, the technology. There's some sputtering techniques that we're coming into to where we can get the same rate of deposition. Well, I shouldn't say that, that's not correct. The same amount of deposition with half or maybe even a third of the electricity input. And that's huge. In our business, that's huge. And so when we're setting up this new coding, we're putting the internal control systems to allow us to do that. So, we're hoping to become a better corporate citizen through this process. One more question. Is that it?
Okay.
One more question.
Since your industry is so capital intensive, how flexible is this change to new technology?
It's fairly easy if you've got the money. But I'll just throw this out as a business model just to think about on my way out. That you have a bunch of people that are really smart and can design some really great devices, but they can't get the money up to produce it. So you have large-scale producers throughout the world, and what they do is they produce for these other guys, sort of like Intel's model on the computer chip, to where they go to somebody that will make their device for them, and then somebody else could do that also. So what you're doing is concentrating your capital investment to where it'll be paid off faster and it'd be more flexible to change. Just a thought. Maybe somewhere around Northfield, maybe.
Thank you, Dwight.
Well, thank you very much.